Hi guys, welcome back. I'm Khaliltronics. Here is another questions. To determine the integral of these functions. Integral of this function using what partial fraction. So it seems to be somehow, but it is also simple. So what you need to do is to just look at the function inside the integral. So as we see, we have the integral of 3x squared plus 18x plus 3, and then all over 3x squared plus 5x plus 2. So we have both quadratic, that's 2 polynomial. So we have to use by integration by partial fraction to evaluate the integral. So actually, by looking at the properties of partial fraction, there is no way you can solve this rather than to dissolve it into long division of what polynomial. So we were given the equation as 3x squared plus 18x plus 3 all over what 3x squared then plus 5x plus 2. Then so to do integration by parts, you have to make this the denominator is higher than the numerator. So how can you do this? So by dissolving this into a long division of polynomial, you'll be able to make it in such a way. So let's start by taking into a long division of polynomial. So we'll call this one to be divisor, and then you can call this one, is this quotient O. So since this one is the denominator, so we can call it divisor. So we just do like this. Let's say an indicator. So maybe if you like, you can do like something like root. So we'll put the divisor inside. Let me take it down so that all of you could be able to understand. So basically I would say let's do like this. I will have something like this. I will put my divisor here, that's 3x squared plus 5x plus, is this 2? Yeah. So sorry, I mean it's negative 2. So negative 2. Yeah, also should be negative 2. Also here should be what? Negative 2. Okay, so all you need to do is to just put the divisor here and then do like this, something like this. Maybe if you like, you can do like roots. So you can put the numerator here, the denominator outside. So our numerator will be like here. The one something at the top will be inside the, let's say, the root. So we have 3x squared plus what 18x plus what 3. So assuming that we have something like let's say 3x squared all over something and then divided by, let's see, something by something. So we have 3x squared at the top, and that one way at the bottom we have 3x squared. So when we say something, this one divided by this one, like we are trying to say this one cancel this one, so we have 1. So if it is like let's say 6x squared plus 7x plus 6 all over 2x squared plus, let's see, here is 2x. If it's let's see, here is 2x plus, let's see, 7, we can say this one by this one, then we can have 6x squared all over 2x. Then we can see goes with this, when we have here 1, here 3, then we have 3x. Then we can put 3x here. But in these questions we have both the coefficient of x squared as what the same. So we can say 3x squared by 3x squared will have what 1. so we can come back here and put it. So just use the bracket here. Let's put bracket. Okay, so we'll also say this one, the one that we have here, multiply by this one, whatever inside the divisor. Then we can come here and see this one multiply by this 3, we have what, 3x squared, and this one also multiply by this 2 5x, then we have what, plus what, 5x. Then we have this one also multiply, you can say this one by this, that's multiplication between them. So this one times this one, we have 1 times minus 2, we have what, minus 2. Then we don't then come here and subtract the lower one from the higher one, that's from top to bottom, just subtract. So by subtraction, 3x squared minus 3x squared here is 0, and then this minus this, we have what, we have if we subtract, we have this 13x, yeah, and also if you have sorry, I had a call. Okay, so we can now say if 18x minus 5x, we have 13x, then plus 3 minus minus 2, we have what, plus 5. So we can then say this is what is negligible, then we have what, 13x over what, 5. 13x, I mean plus what, 5. So we can then come here. This one is just an indicator, no need to put this or this. So since we got this, we are having this, so we can say the whole expression that we have, that's 3x squared plus 18x plus 3 all over 3x squared plus what, 5x minus 2, it should be equal to what, this what you have here. Here is our remainder, that's our remainder. Here is our divisor. Is this divisor? Oh yeah, it's cohesion. I just forget. So we can come here and say we have our quotient, that's 1 plus our remainder. We have 13x plus 5 all over what, the divisor. Our divisor is what, 3x squared plus 5x minus 2. So we have this. So this expression will be equivalent to this approximately. That's, sorry, I not approximately, will be equal. So let's clean this. So I hope you get this, how to use dissolve it into partial fraction. So just divide this over this, and then this expression is going to be equal to the quotient plus a remainder over divisor. So you then finish. The reason why we dissolve all this into a long division of polynomial, there is no way we can solve this since the coefficients of the x square, the highest degree of the numerator and denominator are the same. So we have to dissolve it into long division so that the denominator will be higher than the numerator. So since the integral of what, 3x squared plus 18x plus 3 all over 3x squared plus 5x minus 2 is equal to this, so we can say integral of 1 plus what, 13 x plus 5 all over 3x squared plus 5x minus 2. let's call it in bracket, then we can put what x. So we are trying to find this using partial fraction. So as you see, the one we have right here, we have this. So as you see, our issue is this, so we have to dissolve this into partial fraction. So as you see, the highest unknown, that's the degree of the x square, is higher than the degree of the denominator is higher than the degree of the numerator. Here is x square, here is 1. So it is good to go so that we can apply partial fraction. So let's take since the only problem is here, let's consider here. So we can then come back and say 13x plus 5 all over 3x squared plus 5x minus 2. So we have to factorize this. To factorize this, we can get two numbers such that when you multiply this, it will give you this times this, that is give you minus 6. When you sum it, it will give you 5. So we can say 13 x plus 5 all over what? I have 3x squared plus the two numbers is 6 and 1. If we add them, 6 and minus 1, if we add them, it will go to give you 6 minus 1 is going to give me plus 5. If I multiply it, it will going to give me minus 6. So it's good. So we can say plus 6x minus x, then what? Minus 2. Then I can now say this 13x plus 5 all over this 3x out, then we have x plus 2. Here we can say I have minus 1 into x plus 2. So we have x plus 2. We have both, they are common, you can take 1, then into 3x minus 1. So we have got this. So we need to replace this instead of this. So let's clean. Let's continue like this. So we know that our integration. So we know that our this thing that we have 15x plus 5. Is this plus 5? Let me confirm. Yes, plus 5 all over what? All over 3x squared plus 5x minus 2. All this is going to be equal to 13x plus 5 all over what? X plus 2 into 3x minus 1. So it's good to go. We can use partial fraction, saying that a over the first one, that's x plus 2, plus b over the second one, that's x 3x minus 1. So we can say our 13x plus 5 all over x plus 2 3x minus 1 is equal to what? A all over x plus 2 plus b all over 3x minus 1. So we are trying to find the value of a and b so that we can substitute and then also evaluate the integral. So to find a and b, we have to clear the fraction by multiplying through the denominator of this by this. So if we multiply by this one goes, then we have what? We have, if we multiply through this one multiply by itself, it's going to be equal to 1. Then 13, we have 13 here is Let's me 13x. Yeah, I think it's 13x. It's going to be equal to 13x plus what, 5. So, and then if I multiply this, all this I multiply through by here, let's say x plus 2 and then what, 3x minus 1. So here goes with this one goes with this one, then I will left with what, a into what, 3x minus 1. And then put the other one, if I'll multiply by all this, that's x plus 2 what, 3x minus 1, then this one go with this one, then I will left with what, b into x plus what, 2. Then it's good to go. So we have this, let's call it equation 1. So we can find a number such a way that when we put the value of we find a value of x in such a way that it will tend to be equal to 0. So for here, if we say let our x be equal to minus 2, then minus 2 plus 2 is going to be equal to 0. Then 0 times b is 0. So if this one goes to 0, then I will be able to find value of a. Likewise, if I make a to be equal to 0 by putting the value of x to be equal to what, 1 over 3. If x is equal to 1 over 3, 3 times 1 over 3 is 1, 1 minus 1 is 0. So all this is 0, then I will a cancel, then I will be able to find the value of v. So let firstly make b to be equal to 0. So I'll make b. So by saying that let x to be equal to what, minus 2. If I put minus 2 here, I know minus 2 plus 2 is 0. So that's why I put x to be equal to 0. So any place I see x, just I replace it at what, minus 2. So I have 13 into what, minus 2 plus 5 is equal to what, a into what, 3 into minus what, 2 plus what, 1, I mean it's minus 1, and then I know definitely b is going to be equal to 0, but let's put that's minus 2 plus 2, then this becomes 0. So I will left with what, a. Then I have 13 minus this is this 13 minus 13 times minus 2, I have what, 26 plus what, 5 is equal to a into, here is 3 times minus 2 is what, 6, then minus is 7, that's minus 7 here. So I can now come back and say I have minus 7a here, and then for here I have minus 26 plus 7, that's minus 21. Then I will have a is equal to what, minus 27 all over what, minus 7. Then I can say a is equal to minus 27 by 27, sorry, it's 21 by 7, a should be equal to positive 3, that's 3. So I can now use my equation 1 also to make the a to be equal to 0 so that I can find b. So I have what, 13x plus what, 5 is equal to what, a into what, 3x minus 1 plus what, b into what, x minus 2. So how can I make these terms, that's terms a to be equal to 0? So if I put this x to be equal to 1 over 3, then 3 times 1 over 3 is 1, then 1 minus 1 is 0, then 0 times a is 0. Then I can left with b so that I can find b. So let's say let x to be equal to what, 1 over 3, then I can say 13 into 1 over 3 plus what, 5 then it's equal to what, a into what, 3 1 over 3 minus 1 plus what, b into 1 over 3 minus what, 2. Then here I have it's come yes, so here I have 13 by 3 plus what, 5. Here is equal to, this goes to 0, so I have b into what, 1/3 minus what, 2. Is this minus 2? Let me check. Is this minus 2 or plus 2? It's plus 2, sorry. So here is just positive. So here is positive from the equation 1. Let's confirm. Yeah, from equation 1 here is positive, so we can use positive also. So we can say here is positive. So here by taking LCM we have what, 3 into 13, then plus 3 times 5 is 15, and also here is equal to what, by LCM we have what, 3, we have 1 plus, that's 6. So here to 13 plus is this 15, we have what, 28. So we have 28 by 3 is equal to b into what, b into 7 by 3. So we can find value of b, we can say cross multiply, so we can have 28 times 3 is equal to 3 times 7 times b. Then here we go. Then we can have b is equal to what, 28 by what, 7, which is what, 4. So we have a, therefore we have what, a as what, we have a as 3, and also we have v as what, 4. So we now come back to our normal equations, that we have integral of what, we have a all over what, x plus what, 2 plus what, b all over what, 3x minus 1. So this is equal to what, a, we have a as 3 all over x plus 2, and then plus b, we have v at 4, b is equal to 4, and 3x minus 1. But initially we have what, initially let me see, initially we have this, so we have to include 1 also. So since all this that we have got, all this we have got it, so we have to include our 1, and also is the integral. So our equation is like, we have integral of what, 1 plus we have 1 plus 13x plus 5 all over 3x squared plus 5x minus 2, and also equal to integral of what, 1 plus this one, the whole this one, 3 all over x plus 2, and then plus 4 all over 3x minus 1, then what, dx. And then we can come out and then we can say, since it is some rules, so we can take individual integration, we can integrate individual term. We can say integral of 1 plus integral of 3 all over x plus 2 plus integral of 4 all over what 3x minus 1, all with respect to what x. So then integration of integral of constant term is just x, then plus what here we can see 3 into what 1 over what x plus 2, and then plus what 4 integral of what 1 all over what 3x minus 1. But remember, from our table, if we have an integral of 1 over x is equal to what ln x, and then if you have integral of what 1 over what 3x minus 1, simple means just differential of this inverse, then 1 over 3 ln of whatever is here, then 3x minus 1. So we can apply it here already. So we integrate this one, so you can say x plus what 3. So here we don't have problem, the coefficient is 1, just multiply, then ln of what x plus what 2, and then for the last time is 4 ln of what, so we have the coefficient of x, then we can say over 3, then ln of whatever is. So the final answer is what? So the final answer for integral of final answer for what 3x squared plus what 18x plus what 3 all over 3x squared plus 5x minus 2, then dx is going to be equal to what x plus what 3 ln what x plus 2, and then plus 4 over 3 ln of 3x minus 1. So this is the final solution. Don't forget to like, comment, and press bell icon. Thank you for watching. See you in the next video.